you so much for joining here. It's exciting to see such a full audience, and I am actually excited to be back at Zurich, first of all, because I lived here for a long time, and just a month ago I moved out of the city, but it's always a pleasure to come back. Although I have to say I only live in Argo, so it's 20 minutes by train. It's not too far away. So today I will be talking a bit about Roche and what we're doing in the Kubernetes world. So before we dive in here, let me give you like a quick overview of like what I wanted to share with you today. So first of all, a quick introduction again. Who is Roche? Then I will talk a bit about what is the edge. So you've seen it in the title. Why is it important? Why is it hard to do edge computing? And then on the last two sections here, I have a bit of like an overview what we're doing and how we're doing it. And if there's time at the end, I will have a random deep dive on Secure Boot, but we have to see if I will have enough time for this. All right. So first of all, can I get a quick show of hands? Who knows Roche? Okay, that was an easy one. This is a talk in Switzerland. So maybe, you see here on the top left, right? Roche is a very old company. You could say it's kind of like a dinosaur. So maybe another question here, who would have expected Roche to kind of show up at such an event and give a talk about Kubernetes? Okay, like two hands. Perfect. No, I want to maybe give you like a bit of context here about the inner workings of Roche, right? First, because I think it's important. So on this slide, what we can see basically in Roche, there are like two major divisions that are in this company. On the right, you can see the pharma part. So this is, I think, the part which like Roche is most known for, right? So this is basically research and like creating and producing medication. I think like one of the main fields of work for Roche is like in oncology, so cancer therapies. But what is maybe a bit less known is the part here on the left, which is that Roche is actually also doing diagnostics. So where on the right side, it's more about treatment, right? You know what the patient has, you give him like the right medication. On the left side, it's more about figuring out what's wrong, right? And Roche actually is a large manufacturer of like lab devices, which do analysis of like all kinds of samples, right? Blood samples, DNA samples. We all know a very unfortunate case, I would say, which was COVID. So Roche produced some of these like antigen tests, right? Like these quick tests you could use. But actually, what is also an interesting thing is that if you think about the COVID PCR tests, I don't know the exact numbers, but I just know that like a large percentage of like all global PCR tests for COVID, they were done on like machines produced by Roche and sold to labs. Now, actually, you can see here on this previous slide, there is a third bar over there, right? The digital health, and this is kind of new. I think when I joined Roche like 3 years ago, I didn't see it this prominently in the slides. And the question is maybe a bit like why software is important in healthcare. And here on this one, you can see like a very, future-looking idea, right? Like we want to get basically to more personalized healthcare, not like having one drug which kind of like is fed to all patients and then has like large side effects, but to basically more and more target those medications to really individuals. This is like a long-term vision, right? But like even on the short term, my wife is actually, she has been working as a nurse for a long time. Now she's a doctor, and I cannot count anymore how often she complained about the terrible state of software in hospitals, or the non-existing state of software, like where you have to do stuff on papers and so on. And I mean, we all know, right? Like there's so much potential for automation and like reducing like the toil work which like healthcare workers have to do, right, in their day-to-day job, and also to kind of reduce the potential for errors and mistakes which are happening. If somebody accidentally is like prescribing a drug and like putting the wrong dosage, like putting an extra zero at the end, or somebody is misreading this, these can be like dangerous things, right? And like software could basically help to prevent such mistakes. Now, by the way, this talk is a bit like, I will not show you any code, unfortunately, today, but I will have like a few hints to some other talks we did in the past at other conferences where we have some more deep dives onto like specific topics we're working on. I think maybe this is more about like an end user journey, basically about the thing which Andreas mentioned before, how to make platform engineering in a company. All right, so talking about the edge. What is the edge actually? And I think this is a word which is kind of overloaded, and like it can mean many different things. But this is a picture of what is the edge for Roche, right? So this is like a molecular lab, which you could, for example, find in a hospital. So when somebody draws your blood, it goes into one of these. Not all of them look as big or as nice as this 3D rendering here. But on a high level, you can see here, they're like machines which kind of prepare samples, they're analyzers which make different kinds of tests. You can even see some conveyor belts going between these machines or storage units. And I actually have like a nice animation here on like what's going on inside of these machines. And you can already see, right, like this can be like a very automated workflow in the end. And the question is a bit like, okay, you have these labs, right? Like they have to run kind of like on an automated basis. So you need some software. And question is, how do you run software which kind of runs these labs? And this is a bit where the edge topic came into play for us. And first of all, I don't want to shit on the cloud here, right? Like the cloud is an amazing tool. There are good reasons why it had such a big success story over the last years and decades, even at this stage. But I think over time, like we also realized there are limitations, like when the cloud is like a good fit. And you can see here like a few of these limitations, right? So privacy is actually a big concern. So we have many our customers, right? Oh, and they didn't mention these labs. Typically, they're not owned by Roche. So Roche is selling devices to these labs, but they're independent companies which kind of run and then operate these. So privacy is a big concern, right? Like we're dealing there with like individual patient data. Not everyone is comfortable with sending this to some other person's infrastructure and like basically giving up control about what is happening with this information about patients. I think also connectivity is a big concern, right? Like these labs, they can be fairly critical infrastructure. So you can imagine, right? Like in a hospital, actually, the way it works, often like you have a surgery. During the surgery, you need to run like a quick sample of something. This goes to a lab, and like during the surgery, you're already expecting results from the sample. So like these are kind of critical things, right? If the lab is down, the hospital is down, and potentially you have to abort surgery, which you don't want to do. So like these are typically heavily firewalled environments, often even with no connectivity to the internet. There's also like this bandwidth and latency topic here, which is like maybe an easy thing to do, or like not as much of a concern if your test only gives out a number. But if your test gives out a gigabyte-sized image of a tissue sample, you don't want to upload these images to the cloud just to do some basic analysis on those. So yeah, this is edge. So we want to run basically software on-premise, right? On-premise in the lab. And the question is maybe, why is this hard? Why like, can't we just give them an exe file and have them run it, right, on their Windows machine? Before we go into the actual why, let's actually look at how it works today. So if somebody wants to deploy a software in a lab, such as we, right, the way to do it is typically you have to build your own hardware and to sell the software as a device. And you can imagine that this is not great, right? Like if you think back about the picture of this bigger lab I showed you before, there's a lot of software in this lab. If every software comes with its own hardware, like you end up with a big messy room of all kinds of different form factors and devices which kind of run all these algorithms and then so on. Then also think about like the day two operations, right? Like how does it work today? So again, I mentioned it's about hardware, right? So you send a new hardware, or you put it on a USB stick and you get someone in a car and drive there to kind of deploy it locally, which also doesn't feel like very 21st century style of operations. And you can imagine, right? Like this is all very expensive. So, I mean, if you want to build a tiny piece of software, you also have to find a team who builds the hardware for you and to maintains the operating system and so on. So this is expensive. And I think the result of this is just that like many interesting applications for software are just not happening because it's like why it would be worth investing this time into building this piece of software, doing all the other effort as well, then just suddenly you don't have like a business case anymore. Cool. So why is changing that actually also hard? So okay, this is a slide with a lot of text, but basically the problem, or like a few of the problems we were facing, right? These labs, as I mentioned, they are run by independent companies. So they have their own IT staff, if at all, or they maybe contract out the IT operations to other third-party companies as well. And every lab, and there are plenty of labs out there, so we can think about tens of thousands here around the world, right? Every lab basically has a completely unique network setup, which is not very easy to kind of integrate in, right? Also, how to deploy stuff, right? Like we actually have these labs all around the world. I mean, obviously here in Europe and the US, but like really on every country. And like if you want to deploy something on site, you have to go there. And like not everyone speaks English, so we cannot send our engineers to every lab. So you need to have local staff who are maybe not developers, right? Who kind of have to deploy the computer infrastructure. Then I mentioned the connectivity constraints here. I just want to give a shout out. I don't know if there's a way to upload these slides afterwards, but if there is, you can find a link in there for a talk which some colleagues of mine gave about how we solve a bit this connectivity issue on our platform. Then there's cost constraints. So it's just that like there are big labs as the one I've shown in the beginning, but they're also very, very small one. Like you can imagine one in like a less developed country where like it's just a small room, there's a laptop standing somewhere on a desk and like a small analyzer next to it. And I mean, they cannot afford to pay like tens of thousands of dollars for computer infrastructure. And last but not least, there is also like remote operations. So if there's so many deployments out there, how do we fix issues when they are appearing in the field? So we want to have some ability to kind of connect remotely for debugging, but then also we have to comply with local laws and regulations, which often require like data to stay like in a certain country or political region, which is also a big challenge. And I actually have another last but not least I just realized. Deploying software in the cloud is kind of like, I mean, it always looks similar to this picture, right? You have like a few environments, you have like a dev, staging, prod environments, maybe you have like a few more for developers to work in during development. Now, the problem is, if we're deploying to the edge, it looks more like this, right? Like there are thousands of environments we have to take care of. And if you're actually curious how we do that using GitOps, there's another talk from ours from GitOpsCon where we talked a bit about like how can you scale GitOps to like thousands of repositories. All right, moving on to how are we doing it? Well, I mean the TLDR is we put Kubernetes into labs. I guess you guessed that from the title of this talk. I think basically the reason why we settled a bit on Kubernetes here is that Kubernetes, we can almost treat it as like the new style operating system, right? As a developer, we no longer build applications for Windows or for Linux, but we build it for Kubernetes. And Kubernetes has some great advantages there for us, right? Which is it's horizontally scalable on cheap hardware. We don't have to always bring like server grade, very expensive hardware into these labs. It's possible to do high availability deployments, so we can create multi-node clusters. Again, I mentioned labs are critical infrastructure, so it has to run all the time, right? And last but not least, these lower 2 points there, it's just an amazing ecosystem, thanks to all the great work here by the CNCF Foundation and like all the developers who are contributing. So it's widely used, there's great documentation available. Almost everybody knows Kubernetes at this stage, at least to some degree. Which also helps a lot with like adoption. So how do we do it from an organizational perspective? And I could see a lot here basically from what Andreas has shared in the previous talk. I mean, we're doing basically what everybody's doing, building an internal team, which kind of provides this platform to the rest of Roche, right? So basically in this team, we are responsible to kind of roll out Kubernetes clusters to these on-premise locations. And the overall idea is obviously that the application developers, they don't have to worry about all of this anymore, and they can just work on their application code. Now, it sounds easy, right? Just install Kubernetes. But there are actually a bunch of challenges kind of like around this, and a bunch of questions we kind of had to kind of think about, right? First of all, which hardware do we run on? What is the operating system we want to use on, for these clusters? How to keep the operating system up to date? And especially since we're not in the cloud here, we cannot just throw away the hardware and put new one like we would do like with immutable infrastructure in the cloud. How do we prevent like configuration drift of these deployments over time? How do we bootstrap a new deployment? So as I mentioned before, people who are going on site to kind of deploy such a cluster, they are not technical people per se, right? They don't know what Kubernetes is, so they must have an easy way to set up such a device without using kubectl. Then which Kubernetes distribution to use, obviously, what is the network interface or network implementation we want to use? How do we monitor all these devices? How do we connect remotely to these clusters for debugging? How do we actually keep an overview, right? Like how do we know which clusters are out there? Just to have like an inventory, right? And which versions are they at? I don't have answers to all of these questions for today. But I mean, obviously there is a big tech stack of like awesome open source technologies we're using in this. I guess you've seen plenty of the logos. But I want to highlight a bit the section there on the bottom left, which is about the fact that it's not enough for such a platform to just like toss together all these tools and hope somehow they will work for the end user, right? For us, it's actually very important to kind of hide all this complexity behind some custom-built automation UIs, APIs, to make it usable by these field service engineers who go on site. Yeah, I wanted to give a shout out to one thing here though. I'm wondering actually, who has heard of Talos? A few hands, okay, more than I was expecting. It's a very awesome operating system. We have been starting to use now as like our OS to kind of run these edge machines. For those of you who don't know, right, it's a purpose-built operating system, and the laptop was gone. It's a purpose-built operating system for Kubernetes. So it's really just, you can imagine it as, it's a kernel, it's a kube API server binary on there, and like just all the absolutely minimal components that are needed to run a Kubernetes cluster, not even a shell. So you cannot SSH onto this device and like run commands and edit the file system. Which is awesome from a security perspective. It's also awesome because the entire operating system is immutable. So this configuration drift issue, which I mentioned in the beginning, it's not really there with this OS. And I think we actually have time for a bit of a deep dive here on Secure Boot. So Secure Boot is basically solving a bit like one of the like major security issues we have, right? Because these labs, they're not airport security zones. They are not data centers, which have like very fancy security doors to get in there. So basically the question is like how do we solve this physical access security problem, right? Like these clusters, they contain, again, confidential data about patients. What if somebody just walks into a lab and takes out the machine with all the data on it? And the solution for this is basically Secure Boot and full disk encryption, right? And I wanted to kind of mention this because we actually worked together there with the company of Cilium Labs, which is the company maintaining Talos, which is completely open source, by the way. And we basically contributed a feature there to kind of enable this setup, right? So for those of you who don't know the details about Secure Boot, it's basically a way how you can encrypt the data on the right side at the hard drive. But the key basically lives on a security module, which is basically built into every modern desktop computer, like a TPM chip. It was actually kind of like introduced by Microsoft, I think like 10, 15 years ago. So the nice thing is basically, okay, you have the key embedded in this hardware security module. You have the software which can kind of load the key. But how do you ensure the software which loads the key is actually allowed to load the key, right? Why is it not like a kind of like a malicious OS which the attacker installs on the device to kind of decrypt the hard disk? And the nice thing is basically what you can do with secure boot is you can sign the OS images and the kernel and so on with like your private key infrastructure, and then you can configure the BIOS on these machines to only allow booting of like signed images. And basically with this we have like a full chain of trust, right? The BIOS only loads signed images or signed OSs. The OS can then load the key from the TPM only if it's one of these signed kernels, and then it can access the data on the disk. So even though somebody could take away the machine, typically they don't get access to the data because the only system they can actually run is the original OS we kind of intended to run on this device. And that is actually almost it. We're also hiring, by the way. So we're located currently in Switzerland, in Spain, and Canada. Currently, we're looking for some new engineers in Spain. So I guess you're not looking forward to move to Barcelona. If you do, I mean, please apply. But if you know someone over there who kind of wants to work at an exciting place, please let us know. And with that, I'm curious if you guys have any questions.
Thank you so much. Are there any questions?
Hi, thanks for the talk. Which Kubernetes distribution are you using and why?
That's a good question. So we're actually using Talos now. The nice thing about Talos, it basically has a built-in distribution. So before we had a setup where we used, what was it? A breed of Debian, I would say, plus RKE from SUSE, which was also a pain because we had to maintain these two things kind of separately. But now with Talos, basically, there's just one package. You get a Talos version that contains the kernel and the Kubernetes binaries.
It's pretty interesting because, I mean, you work in a relatively sensitive environment, and I would expect that you would use something with commercial support behind it, like OpenShift or...
Yeah. No, it's actually so that's an interesting question, right? Like we actually do use a lot of open source technologies in our platform, but for those really critical pieces, we try to get some commercial support as well. So for Talos, as I mentioned, there is a company behind this. It's called Cilium Labs. They offer commercial support. Yeah, but we also have plenty of developers in our team, so if there are issues, we're able to also fix them ourselves. But it is actually, so this is actually an interesting thing, right? Like it is possible, even in such a regulated industry as healthcare, to kind of use non-commercial software.
More questions up there.
All right. You mentioned about encryption at rest. I was just curious, is encryption in transit a requirement in your industry or it's not?
Yeah, it absolutely is. So we have to encrypt the data at rest and also in transit. So all the like HTTP connections, they have to be HTTPS and so on.
Okay, thank you.
I think there's one more over there.
Right behind you. Couple of rows.
Thanks for your talk. You mentioned that one of the hard things is updating or upgrading your Kubernetes cluster. So how do you handle it now?
Oh, that's a very long story. So actually, I think like the short answer here is Talos helped us again a lot with this, because with Talos, basically, the way you configure Talos, it's only like a YAML file, like a declarative configuration. So for example, to update Kubernetes and the OS, we just have to basically declaratively give a new YAML file to the Talos OS, and it basically updates itself.
The internet.
Through the cloud, exactly, yes. It's actually an interesting question, right? Like, I mean, I mentioned connectivity is a big topic. At the moment, all the clusters we operate, they are sitting in labs which do have at least some level of connectivity. However, even like fully air-gapped is a big topic on our side, and we're actually working on that at the moment. And then it's like, yeah, another challenge, I would say.
Further questions? One over here, one over there. Almost.
So you just talked about Talos and the updates. What does immutability mean for Talos in this regard?
Yeah, so that actually means that basically when Talos boots, the root file system is mounted read-only. So there are just a few basically specific folders which are used for mounting volumes from workloads on the Kubernetes cluster, but all the OS directory and file systems, they are read-only and cannot be modified. So when you update this, basically what happens is it like installs like almost like a new snapshot in parallel. It does a reboot and loads the new snapshot. If something doesn't work, it can go back to the old one. But basically, Talos is like the entire OS is contained in the kernel image. So it's just, I mean, I don't know how much you know about it. There's the kernel, and then there's this initial RAM disk. So it's all contained in these ones. So you just have two kernels then installed. Yeah.
Thank you.
Many more questions.
Thank you for your talk. It was really interesting. I was wondering, how do you manage backups of data which is at the edges? I mean, how do you go about that?
So we didn't solve that one yet. No, I mean, at the moment, we're basically running only stateless workloads, which are not that sensitive about losing their data. But it's actually one of the items you want to look into. And figure out how to do it. But I guess, in the end, it's always a question like, okay, you have to put the data somewhere, right? Either you rely on some persistent volume manager on Kubernetes, which kind of can distribute the data on the different nodes, or you upload it to some external storage, either on premise or in the cloud.
Thank you.
Awesome. There is a question over there.
So I was wondering what your concrete disk setup is, and if you're also encrypting the read-only disk, if you do like the DM-Verity there, or if you then also have like a status for like the container which are installed or loaded onto there, maybe as a more dynamically. If you encrypt that, so what's the concrete setup there?
So basically, on the disk, everything is encrypted except for like the binaries of the kernel, because this one they have to be read by the BIOS. But everything else is encrypted, basically. It's like a full disk encryption.
And you don't have everything, you still have two disks, right? Because you mentioned that the Talos one is immutable, but you still maybe want to have like not all the containers on there, and you maybe want to download them from okay, so you have still two disks. I
mean, we have basically two partitions there. There's one partition, which is the boot partition. This contains the bootloader and the kernel. And the other partition is basically the data partition, which is read-write, because this is the partition where the Kubernetes volumes live on and so on.
All right, thank you.
There's one question right up there. Before...
Hello. Thank you for the nice presentation. Thank you for sharing with us. I have a question about TPM. So there are a couple of known vulnerabilities with TPM and how they can be exploited. Did you already resolve that part? Because, I mean, in theory, someone can take a device and spend as much time as needed with it. They have physical access. And with TPM vulnerabilities, you could get the key in like minutes with a nice, decent penetration attack. Did you do any kind of analysis on the penetration side, or maybe risk assessment for the device, or maybe, I don't know, bug bounties or something to see if people can actually grab that key from the device? And if you have some plans for the future? Okay.
No, so this is actually something we're doing. I think, in the end, like there's never 100% security. So like in the end, like you have to accept certain risks. But like we figured that this is kind of like a good compromise between like cheap hardware and like good enough security for these use cases.
There was a question down there, and then the last over here.
Thanks. You mentioned that you talked to the developers they had to develop the software in a Kubernetes native way, not for Windows and others. And in our case, that's the hardest thing I think. Are the software you run on Kubernetes clusters, are they developed by yourself, by Roche, or are you on a vendor?
So at the moment, most of the software which is running there is developed by Roche. So it's really like systems we're developing, for example, for automating these lab workflows. So it's like internal development, which I guess makes this a bit easier.
Yes.
Yeah. Thank you.
Awesome. The last question over here.
Okay, so thank you for the talk. I had a question about Talos. I don't have much experience with that, but you mentioned that you can't SSH to it, and there's only single way to access it with an API. So does that make it also a single point of failure? And then how do you even mitigate any like failure, like in general, like if there's a big failure, and then how do you even access it as a backup or something? Is there any way?
Yeah, it's a good point. I mean, to some degree, yes, it's a single point of failure, just as like the SSH server is like a single point of failure, right, on like another OS. I think in general, the way we try to kind of mitigate this risk is a bit by going towards like multi-node cluster deployment. So if a single node is having an issue, the other ones are still working. But like in general, like the API for Talos, it's a very critical piece, right? So like they're putting a lot of effort into making sure this is always up and running. And you can imagine this API, like really it does only allow to kind of do like very few things. You can, for example, get some logs using the API from like the Kubernetes master services. You can, what else? Change the network configuration, change IP addresses, like these basic configuration settings you can basically do via the API, but it's just like a very thin layer, basically. Cool. Thank you so much,
Thank you very much. Round of applause.